Welcome to Summarize Science, where we look at the latest breakthroughs in technology. Today, we are diving into a paper titled Reconstruction Matters, which focuses on how self-driving cars see the world. For an autonomous vehicle to navigate safely, it needs a bird's-eye view, or BV, of its surroundings. This is essentially a top-down map that combines images from all the cameras around the car. The problem is that most current systems treat this mapping process like a black box. They take 2D images and try to guess the 3D layout without really understanding the geometry. The researchers behind this paper argue that this lack of explicit 3D understanding leads to errors. They propose a new framework called Splat2BV to fix this. Instead of guessing, they use a technique called 3D Gaussian Splatting. Think of this as the car painting the world with millions of tiny, fuzzy 3D dots to reconstruct the scene in its mind. This creates a much more detailed and accurate 3D model of everything around the vehicle. By first building a 3D world, the car has a much better foundation for making driving decisions. The framework works in 3 main stages. First, it trains a generator to reconstruct the 3D scene from simple camera inputs. To help the car understand depth, they even use specialized vision models that act like a digital tape measure. This ensures the car knows exactly how far away objects are in the real world. But just knowing where things are isn't enough. The car also needs to know what things are. The researchers incorporated a model called Dino to inject semantic knowledge into the 3D dots. This means the 3D reconstruction isn't just a bunch of points, it's a map filled with meaning. The dots represent specific features that help the car distinguish between a sidewalk, a person, or another vehicle. Once the 3D scene is built, the system flattens it into that top-down bird's-eye view map. Because it comes from a high-quality 3D model, the resulting map is incredibly precise. This map is then used by the car's AI to plan its path and avoid obstacles. The final stage of the process involves fine-tuning all the parts together to work as one cohesive unit. The results of this new approach are quite impressive. When tested on popular self-driving datasets, Splat2BV consistently outperformed older methods. Specifically, it showed a massive 21.4% improvement in identifying road lanes. It also got better at spotting pedestrians, which are often difficult for AI because of their small size. Visualizations show how the car reconstructs fine details like zebra crossings and even trash bins. This level of detail is a significant leap forward for autonomous perception. By making the reconstruction process explicit, the AI becomes more interpretable for human engineers. It is no longer just a guess. We can see exactly what the car thinks the world looks like. To recap, this paper shows that 3D reconstruction is a vital step for reliable self-driving technology. By using 3D Gaussian splatting, they've created a system that understands the world's geometry better than ever. In the future, this could lead to much safer autonomous vehicles that can handle complex city streets with ease. Thanks for watching Summarize Science, and stay tuned for more tech breakdowns.